How did we get to Sesame Street? This will make a lot of sense by the time we get to the end of this talk. But Bert, Ernie, and Elmo are all part of your lives these days. You just don't know it yet. So in the beginning, we had this thing called a hypertextual web search engine. This is back way before probably any of us were even thinking about search engines. And these two guys, Sergey Brin and Lawrence Page, created a paper about how to better index the internet at the time using the link graph. So at that time, the internet was 147 gigabytes of what Google had indexed. I'm sorry, not the internet, what Google had indexed. And so it fit basically on a USB or on your computer. That was the entire Google index at that time. Today, in 2020, about 3.8 billion people use the internet every day, half the world's population. And that was before COVID. There are no statistics right now, but I have a feeling that number's probably gone up quite a bit, given that people have been locked down in many areas of the world for the last few months, including myself. So Google processes trillions of queries a day, query meaning searches, right? So when you go and you search something, Google's doing trillions of these, a year, and has indexed billions of websites. Today, there are already 3.5 billion searches. And in 1 second, there are almost 85,000 searches that Google has to process and bring back a search result for what you put into the search engine. So this is a massive resource pull for them. It also pulls back 98,000 gigabytes of traffic in a second. So we're talking big data. So when Google started, it was 148 gigabytes, fit on your computer or any USB drive you can buy for $8, right? But now they're talking about dealing with petabytes of information. And that is a very different challenge to deal with. So Google had to find a way to deal with all this data. So going back to how Google started, it was found on unstructured data. Remember when you could put a bunch of words on a page and Google's like, hey, you rank for this? That was unstructured data. That's when, and I have extra text on here for you guys so that you can read it later and have it to refer back to. Plus I have links on every page where you can get extra information. Given this is a very heady subject, I want to make sure you have that. So I'm not going to read these to you. I'm just going to summarize. So unstructured data is just information that doesn't really have any organization. It's not predefined. Nobody knows what it means. It's just text in a search that goes back to Google, and Google used things like anchor text and H1s and titles to determine what that page was about. This was known in these circles as a bag of words approach. This is an official term for that kind of search. Otherwise, what we call keywords. So unstructured data used keywords. So if everyone remembers, you always had, and you still need to do this for other reasons, but it's not because of the reasons you did when Google first started. So titles, if anyone is back in the day, they know title tags were like, they could rank your page, just having a good title tag and a good H1, right? And then also term frequency, inverse document frequency. You still hear people talk about this today, and there are purposes for it, but Google's kind of moved away from this model. But this is the other thing that people used back at that time in this bag of words approach. Google didn't know what the words meant. It didn't have context. So it just used the frequency of the keyword in the documents, and it compared it to other documents in the set, and then it saw where they were on the page. But as we queries our searches number in the trillions, then this becomes a very inefficient model for bringing back a result when you type something into search, because they need to process, as we saw, 3.5 billion already today. So enter machine learning. And there's a whole structural change at Google that went on at the time. If you're someone who loves the history of Google, I suggest looking it up because it's kind of fascinating who were the players for at the time. We don't have time to go into all that today. But so this is where machine learning started. So AI and machine learning often get used as though they're the same term, but they're not really. Machine learning is a segment of AI. And so machine learning allows you to build like a predictive model and to make predictions from things that have not been seen before. It also allows you to add semantics and to add context. So from Google, this is their definition of machine learning. It's a branch of artificial intelligence. And you can see here there's many different kinds of artificial intelligence that they use. And basically, it's a way you solve a problem without codifying. So this means that the way Google organic search was originally done, there were engineers who developed algorithms that they could tweak at certain levels to make it do certain things, and they knew exactly what would happen after. But that's a time-intensive project because they always have to, be coding and testing. So machine learning allows Google to do things where they give it a learning set. The code then determines from the learning set what to do and how to predict what might come next. And they use that in all sorts of different kinds of projects at Google. So again, machine learning allows us to solve problems without codifying the solution. So instead of having the web engineers, code a ranking factor and then tweak it, the machine learning learns what these things are. And just a fun fact, neural networks and machine learning are not that new. They started, the first one was known in 1959 to remove extra noise on your telephone line. And for anyone who still has one of those today, it's still in use. So machine learning lets us scale. Remember, we're talking about this petabytes of data, big data. So Google had to find a way to scale search. And so instead of hand-coded rules, machine learning lets you do that better. So Google went from what they called the heuristic model, manually tweaked rules, to one based on machine learning, but they were very reluctant to use this on the core algorithms, the base algorithms of Google. So while Google has used it to pre-process Penguin or with Panda algorithm updates, on the core algorithms, they say they still don't use it to this day. And this is just to give you an idea of, and you can read it later, this is just what the deep neural network is, how it works at Google. And this is what it looks like. So when you put in, let's say, an image, because they're looking at image search here, and they can identify it through multiple layers of this deep learning network, they can come on the other side and know that that's a cat, a dog, a car, apple, and a flower without anybody inputting that information, without that ever being coded. It learns what that is through the learning set that it was originally given. So Google uses machine learning for a lot of things outside of what's here, but I'm just talking about what we deal with in the search engine. So like image search, it's heavily applied. Maps, Google Ads, the automated Google Ad system is based on machine learning. Snippets are rich snippets, featured snippets. Those are all based on machine learning. Pre-processing for organic algorithms, like I said, Penguin, and they don't use it on Penguin. The Penguin has been rolled up into the core set of algorithms, but it's still its own deal. So that they don't use it as part of Penguin except to pre-process how Penguin's going to work. But things like Panda were. They also say they do not use it in the core organic algorithms, like I said. And this is one of the original people that adopted machine learning at Google. You can read the article, but they were saying they're just really reluctant to use it. And why? Because it can get really messy. So when I have an engineer tweak the code to make something rank differently based on, whatever goal we're trying to achieve, then I know exactly what I'm doing. But the problem is when you do machine learning or AI, it does its own thing. The reason machine learning is called they use neural networks is because they're trying to imitate human thought. They don't do that yet, but that's where they're heading. So it can get really messy because, like, if sometimes you say something and then you think it and then you say something else and someone goes, how did you get to there? And you're like, oh, I forgot to tell you the part I thought in my head. Well, machine learning works like that too. You give it input and it can give output, but the people that developed it don't necessarily know why it's doing what it's doing. So this goes back to last Monday. I'm only going to briefly talk about this because we really don't know anything yet, nothing confirmed outside of it was a quote glitch. But they've had multiple quote glitches of late, and I have a feeling, this is my personal opinion, that the core updates are an attempt to use machine learning in the core algorithms. And the reason I say that is because machine learning, the way you do it is you put in the original learning data, You roll it out, you see what happens, then you take that data, you feed it back into it, and then you keep doing that. And we've been having these updates every 3 to 4 months now for, I think it's 3 years now, and they're still not sure what they're doing. So I really have a feeling that is an AI implementation, not an engineer just tweaking a rule. So, and this again is why it's really hard to do ML on those kind of core algorithms, because there is no easy way to fix it. So in a score-based model, the heuristic model, if there's a bug, if they roll it out and there's something bad that happens, all they have to do is, oh, I coded that, so I can uncode that. The ML model, we don't necessarily know what the machine learning did in the meantime. So you have to actually just roll it back and then try for better training data or try to fix some of the parameters that you've used. So where does Google use machine learning in organic search? Like, again, I do think they're using it in the core updates, but I do not have any confirmation of that. That's just a personal opinion. But they do use it in language. So this is the primary place where you'll see Google using machine learning. And this is back in 2012, Google rolled out the Semantic Web, and this is the beginnings of the implementation of machine learning and language, which has developed all the way up till now when we had the BERT rollout last November. And what this is a quest for natural language processing. And you're going to probably hear me say this a couple times, but a lot of people go, oh, Google uses natural language processing. It uses sub-functions of natural language processing in the core of that understanding, but natural language processing would mean if they really could do that, as I talk, you hear me, you automatically know what I'm saying. But this search engine can't do that. It's like an infant. It has to, it doesn't really know, right? So just so you know, just to make that clear though, just so you don't, we're not talking about full natural language. We're just talking about subsets of the academics of natural language processing. So Google moved from relational databases to knowledge graphs in 2012. And relational databases are basically table row, like an Excel spreadsheet. You put the data in and it pulls it out. Knowledge graphs are a bit different. Noting the knowledge graphs have been around for a very long time. So when you say Google's knowledge graph, it's not the only one, which made academics really, really mad because Google took their term that they used for graph-based knowledge representation and turned it into a buzzword. So just remember, when we talk about knowledge graphs, they've been in existence for way before Google, and Google is not the only one. It's in fact an entire science unto itself. So enter semantic search. So semantic search is when you put a search query in, but they're trying to not just pull back something related to that term, i.e. keyword, and why we changed from keyword to query, because query means they're going to try to determine the intent, the context of the meaning the person is using when they search. So semantic search really just means Google's trying to understand intent. And why are they doing this? Because the knowledge graph is the answer engine. Does everyone remember, like, I know you can't answer me, but when Google went from a knowledge graph and started calling themselves the answer engine? That's because the knowledge graph allows them to bring back answers to questions. So these are all part of Google's answer engine: knowledge graph, directions and traffic, direct results, featured snippets, rich lists, and discover. And a lot of these are impacted by machine learning. Featured snippets, rich lists, discover, all machine learning. Directions and traffic, also a lot of machine learning. And the knowledge graph is created via machine learning. The holy grail of search is to be able to understand language and text as I speak it or say it instantly, but they're not there yet. So in 2012, they rolled out the knowledge graph, and this is based on known relationships. So the knowledge graph is just called a graph database, which means it actually exists in a space where everything is mapped out to each other. Was one of the biggest things that they had ever done at that time. So the knowledge graph enables you to search for things like people, places, landmarks, celebrities. Everything in orange is something they specifically cite that they pull up in the knowledge graph. In other words, these are just nouns. So we have these words like knowledge graph, and it all sounds like it's really academic, but it really just means Google has a database of nouns. And these are called entities. So when people say entity search, they just mean noun search. Noun search, though, with relationships. So before we moved to Hummingbird, they had these knowledge graphs, and these are the kinds of things that were in the knowledge graph. They're just specifically items that Google could pull back. But then they added to this knowledge graph relationships and nodes. So now it's not just nouns, but it's also how is it related. So if I say apple pie, it's an apple and it's a pie, but Google knows the relationship between apple and pie is very close, and therefore apple pie is its own entity. And it looks something like this if you were to like try to make a picture of it. So Google knows that the Louvre is a museum. It's located in Paris. So they start associating not just the entities, but the entities with other entities so that they can put them together as, again, the knowledge graph. This is one of the original knowledge graphs that Google used called DBpedia. And this is what it looked like when it was graphed out. This isn't the whole thing, it's just a portion of it, but it gives you an idea of how it looks. So the circles are the entity and the lines are the relationships between entities. The thicker the line, the stronger the entity relationship. So this is when Hummingbird came in and we moved from strings to things. So strings is the bag of words approach where you just type in words. Google doesn't know what they mean, and it's just something they figure out based on indicators to the page, like the links coming in or the title tag. Or so if a dog is on the page and there's an anchor text that says it's a dog and there's a title that says it's a dog, well, then it's a dog, and Google doesn't need to know what that is. But when we moved to Hummingbird, we moved to things, and Google did want at that time to know what the dog is. And then it also wanted to know the relationship between the dog and other entities. So Hummingbird came in 2013, and Google moves from matching keyword terms to trying to process natural language queries using the knowledge graph. But again, the reminder, Google doesn't process language very well. But this is their very, very first attempt. So we're going from unstructured data to the bag of words approach to things, structured data, known entities, and relationships. And I got ahead of myself there. Things are known objects with known or learned relationships. So the learned relationships is the machine learning. So Google originally seeded the knowledge graph with things known from sources like the CIA Factbook and Wikipedia. But as the machine learning was added to it, Google would start to interpret relationships between items based on searches in Google. So the KG is a relational graph with known objects and mapped relationships. That's really all you need to know about that in the simplified form. So the knowledge graph allowed Google to use machine learning to understand relationships so they could better match user intent and understand what users wanted to come back from the search result. Again, it doesn't process NLP, so it uses something called natural language understanding. And we can see here, these are all the different parts of NLP, and Google uses some of the blue, all the green in their development of the machine learning process to understand speech better and the relationships between entities so they can bring back better results for you. So this is called a vector relationship. Now, I know this is all super heady, so I have lots of links on these pages, so you can go and read them if you would like to. So the first machine learning application was Word2Vec. And this is a vector space model. So basically a vector space model means that when I have an apple and pie, Google gives it a mathematical number, puts that in the vector space graph, and then it associates them with another mathematical number to represent the relationship or the strength of the relationship between the words. So if two words are not meaningful to each other, they'll have a very weak mathematical relationship. But if they're very related to each other, they're very, very strong mathematical relationship, and they'll exist in the same place in the vector space. So pie might be a conceptual topic in the knowledge graph, and under that might be apple and blueberry and peach and pecan. And now I'm hungry. This is called the embedded word model. So we moved from the count-based method that's keyword density. If you stuffed 100 words in white text and Google couldn't pick it up, the same one, you would rank for it. But now predictive methods. So that's why things like keyword density and keyword analysis really aren't as relevant anymore, because now Google is trying to interpret meaning and intent and relationship with a predictive method. Now, the vector graph looks a little bit like this. If you're to visualize it, and it shows you how it shows the relationship between them. So Hummingbird added this semantic layer. Remember we were talking before that the semantic layer means they're looking for intent. So we're past keywords, we're into semantic interpretations. So Hummingbird added these to the search algorithms, and they still exist today. So synonyms and close variants. So you'll notice today if you type in something that's a synonym of a word, a lot of times you'll get a search result that actually has the word, the synonym to that word in the result. And it didn't have that under the bag of words approach. Also semantic distance in term and relationships. So if things are together in content, if they're probably related. So if apple and pie are next to each other in a paragraph, then apple pie is probably what we're talking about. If I said apple in one paragraph and pie in another, I could be talking about iPhone and Android. So semantic layer looks at semantic distance and term relationships. Also phrase-based indexing and concurrence. So this is where certain phrases predict other phrases, right? So one is like US presidents, and you know that the terms in there are related to US presidents, where US presidents in the co-occurring phrases may rank lower for US presidents because it has a lot of other things on the page. So that really points to something that's always been important in search, is making sure that your content is very clear and topic relevant. So you can have a hub page that has a variety of topics, but as you get down into the meat of your content, you always want to make sure that you have pages that are categorically related to one topic. So if I have coffee, then I have coffees of the world, and then I have US coffee, then I get down to the US coffee page, and that's specific to US coffee. So you never want to have pages that are just full of general items without sub-pages that bring out the specifics of that category. Page segmentation, where is the information on the page? So Google will still give importance to items above the fold. This isn't just with content, there's other things as well. But above the fold has a Google definition, which I haven't looked up recently, so I'm not going to give it to you, but you can look it up. But this tells Google that this is important, where boilerplate content, like your footer, is not. And then there's entity salience, which just means Google knows something is part of a topic or category without actually having it said. So this page could be about Marvel Comics, but we see Iron Man, science fiction, Pepper Potts, Tony Stark. So this means that these are all related to Marvel Comics. He doesn't even necessarily have to have Marvel Comics on the page for Google to know that at this point. So you could do a search for something related to Marvel Comics, and it might pull up a page that doesn't have that text in the page, because Google knows through the entities, the relationships, and the knowledge graph that those things are related to each other. So, and that's what I'm talking about here, which is the topic layer, the categorical classification that they added in 2018, 2019. So Hummingbird moved us away from the strict word count and into the probabilistic modeling and word vectors and nodes. Nodes just mean relationships. So you have entities and nodes being the relationship between the entities. And this is kind of what it looks like in mathematics. So the closer something is to the other, the math represents that relationship. But again, Google doesn't process natural language in the true sense, so we have to add an interpreter. And this is actually part of natural language processing theory. So you must have an interpreter when you don't have full NLP. So do you use Schema? So I see people on Twitter a lot saying, oh, I added Schema and our rankings went up, and therefore Schema is part of ranking factors or ranking signals. But it actually isn't. There is a reason that your site did better, but it is not because of ranking signals. So structured data is a way for Google to better interpret the the language that it doesn't really understand, because again, it's still an infant in learning how language is in context, right? So in the content of a sentence or the content of a page. So structured data tells Google, this is an author, this is a recipe, this is a review. And then it knows, oh, okay, well now this information in this portion of the page means something related to author versus related to a recipe. So structured data is on-page markup that enables a search engine to better understand the information on your site pages. And that way they can better match search intent. They do prefer JSON, and they are actually telling people now to remove RDFA and microdata, not immediately, over the next year or so. You want to do that and move over to JSON completely. And for anybody who doesn't know, JSON is just JavaScript object notation for linked data, which is just a way to implement the schema outside the HTML markup, which makes it much easier to deal with. You can just put it in the head of the page, and you can even use containers, common containers across pages to do that. And here's some information for anybody who's new to JSON, just so you can have it for later. So why does schema matter? Because before, what we did is we put a bunch of words on the page and we're hoping Google will figure it out, right? But you don't have to do that anymore. Adding the semantic markup tells Google what we say about our site and what the relationships are inside that site. So we act as the interpreter, and we can teach Google the context of our content and make it sure that when people search for that, they get a more relevant result, and you're helping Google with the relevancy. So I'm not just the gray Android bot in here, I'm the green Android bot, and I'm like, hey Google, look at me, and Google knows that this is a different thing than the others. Not that there's really a green Android bot schema, but that's what schema does. So we give our data meaning that Google understands, because Google is not a human, and Google doesn't understand language like you and I do, like you understand as you're listening to me. So that interpreter schema makes a huge difference. Now they think maybe in 5 to 7 years they won't need it anymore, because machine learning will be advanced enough to understand without it. But in the meantime, use schema if you're not using schema, and don't just use Google schema. Google says they will actually use schema from schema.org that they don't list in their developer documents, because the developer documents are for snippet schema. The other thing about schema, it is what they use to identify snippets. You don't have to have it to get a snippet, but you're going to do much better at getting featured snippets, rich snippets, review snippets if you have the schema in the page. So schema makes us happy, and we do better, and we're much more relevant. Google can find us easier, can match the queries better, and so we look like we've gotten a ranking boost, but really what we've gotten is a query relevance boost. So what other kind of machine learning does Google use in search? RankBrain. I actually discovered RankBrain before RankBrain was known, and had an article sitting at Search Engine Land the day that they announced it, which is kind of funny, and then I had to rewrite the article using the word RankBrain. So RankBrain originally was just for new queries. 15% of all queries Google discovered were new every day, which is crazy to me, because like, how many new ways can you say things? But apparently humans can find a lot of new ways to search for things. So RankBrain at the time was used for unknown queries where entities, meanings, relationships were not clear or unknown. Remember, we're talking about the vector relationship and the mathematical graph, and Google's like, oh, these two things don't seem related to each other. I don't really have an answer for that. So the way I discovered it was, I was looking up water rights during a drought in the Las Vegas area, and I looked up water rights for my county. That came up, no problem. I looked up water rights in California. That came up, no problem. I looked at water rights in a place called Pahrump, which is a town about 30 minutes from Vegas. I got a little bit about water rights, but I got a bunch of other stuff. And then I did Mesquite. And Mesquite in Nevada is a town, but it is a very small town, and people don't search for much about it. And it came up with Mesquite barbecue, Mesquite trees, Mesquite water district, but nothing about water rights. And actually Mesquite's very important for water rights in Nevada. And that's because it's not something that RankBrain understood. And so it gave me a kitchen sink result. You can always tell RankBrain's been applied to a query when you get a kitchen sink result. So Mesquite water rights, it had no idea. So it gave me something related to Mesquite, like barbecue and trees. And they gave me something related to water, like the Water Authority. So it completely looked like they were unrelated, but in the knowledge graph, they weren't unrelated. They just didn't know what I meant by Mesquite water rights. Again, the vector relationships that we talk about, that's how RankBrain works. And it's only one of the two algorithms that Google claims they use in the live results. And rank brain just means Google's confused. So Google's like, I don't know. Like, what do you mean by that? So just to give a quick example, this is from a talk I did a while back, and I use the older search results just because I can show the evolution of the query. So I was like, where can I get sweets in the United States? Well, I get sweet sweat as an answer. I get dessert delivery. I get sweet Thomas sweet. Google doesn't really know what I mean by sweets. But sweets in the UK is something else, right? So, sorry, I got ahead of myself because I can't see my next slide. Anyway, so rank brain, the known relationships words go in, they get assigned a vector, they sit close to each other in the vector space with the mathematical relationship. They're retrieved based on your query that best fits the vector. The word interpretations are used to return the results, and if they're weak or unknown, rank brain comes in. Now, rank brain's apparently, supposedly on all queries now, and so this was the original implementation where it was only if they're weak and unknown, but now it seems they use it at some level everywhere. And then behind the scenes, this data is constantly fed into the machine learning process. So as those results get clicks, then Google starts to learn what you think is the best result for that query. Note, this is not ranking factor clicks. I don't want to start that myth, like, oh, you give clicks, you rank better. That's not it. Rank brain just uses queries and clicks to help understand the query intent. So this is this result, right? This is my original one, which had nothing, like no candy, actually, I don't think at all on this one. Here's a year later when I did the same query. The yellows are just the poor matches, but you can see it's starting to understand that sweets might mean candy. But that's not a geolocal result, right? And in Las Vegas, in American English, you don't use it, but we have a lot of people that live here from other places in the world. So my guess is over time, Google learned that sweets could also mean candy. So also what helps understand query intent is geolocation. Machine learning uses that as well, because you can see in London, it totally knows what I mean by sweets. Because in London, sweets are candy. So they even have the nutrition facts for candy, sweets and chocolate on the page, on the knowledge graph. So semantic relevancy, sweets has no definitive entity in the United States. It doesn't have a strong relationship to the word candy, but in the UK it did, so that's why it got a different result. So what other kinds, so we've gotten past rank brain, so now we have another layer. Rank brain has a friend now, it's called neural matching. This was back in 2018, Danny did a Twitter series on it. And basically, it's just super synonyms. So remember how we were talking about Google could start to understand synonyms? Well, that was like direct synonyms. This is more where they can start to infer through users' input over time with the machine learning that change can mean all these different things: exchange, install, modify, replace, switch. And then with the machine learning, they can determine through context which is a better one. So he uses it for the soap opera effect. So soap opera effect, what is it? I don't know, but you see his search result, his search input is, why does my TV look strange? And it's, what is the soap opera effect? Well, that isn't in his query. He didn't ask what the soap opera effect was, right? But they know from people looking for why does my TV look strange, that that is the soap opera effect that people are trying to remove from their televisions. So this is where machine learning has given Google information on how to bring back a better query result with better intent. So what's the difference between rank brain and neural matching? Rank brain is about the concepts, and neural matching is just linking words to the concepts. So rank brain is about the concept suites, and then it brings back a whole search results page, or part of the search results page is affected by rank brain, but neural matching is the words related to that concept. So what's important to note about this, though, these are not ranking factors. They are not used in the scoring of websites. They are only used post scoring. So they're used after to sort on the query side. So you really can't affect a lot about it. So they're not ranking signals. They're just layers applied to documents that have already been scored and ranked by Google. And since it's not applied, and since it's applied post-rank, that doesn't use links either. So should you optimize for rank brain and neural matching? No, because why would you optimize to rank with AI? Now, there is an exception to this. If you're a company and you've created a new term, or you're a new brand, or you have brand terms that nobody else uses, and that's showing weak, you're getting a rank brain type result, then you can take over that result by, optimizing pages towards that query and having your users over time tell Google that's what that query means. But generally speaking, you're going to waste a lot of time and resources because, as you saw, those results changed dramatically in 1 year. So if RankBrain is there and it's changing the results based on an unknown relationship or having to learn the relationship, you don't really want to spend a lot of time on that. You could spend it somewhere else and you could get much better results after that. And even Google doesn't understand what exactly RankBrain and neural matching are doing. This is just a quote from SMX in 2016. They still say the same thing. So the user gets the result that is deserved for the query. So they're always like, this is where Google always says, write better content, write better content, write better content, right? This is what they're talking about. Int, Bert, and Ernie, and Elmo, and I have no idea if I'm going way over time now. I'm close though. So now we had this big update back in November 2019 called BERT. BERT and Elmi are Google's algorithms. Ernie is Baidu's BERT. BERT stands for bidirectional encoder, representations from transformers. Ouch, that's like, what the heck are they talking about? I've given you lots of links here because we'd have to do a whole hour talk on BERT and don't have that kind of time. But so you understand, BERT just means that they can interpret language better and with fewer processors. So it's language modeling, and it can transform the architecture of a sentence. So it doesn't have to know whether the sentence is forward or backwards. So animal, in this sentence, we can see the one side is it is related to animal, but it could be street in the sentence. So BERT is there to help better process before people start looking for something, how these relationships work. Because BERT can go bidirectional, forwards and backwards. Before BERT, it can only go forward or backwards. And it masks words in the sentence and does predictive text. So you can just see, these are just graphs of how it works. You can see in BERT how the arrows are going back and forth through all different things, where the other ones, they only go one direction. And that's because BERT can go both ways. So it's just predicting words in a blank space in a sentence or a query. So this is what it looks like. It's the blank sat on the mat. What word would go there? Well, most of the time, cat or maybe dog would go there. And BERT tries to determine what word would go there, and they don't need to necessarily know the sentence, just context from the sentence. So it sort of looks like this. The old way was forward or backwards, and now the masked way, the BERT way, is it can tell the entire sentence without knowing what the sentence says. It's just, it can predict the words in the sentence, which when you put a query in, helps it bring back a better query. So information on the BERT update last year, the biggest thing you need to know is it doesn't have anything to do with SEO, really. BERT is a processing revelation. It is the revolution of natural language processing right now. That's why it got so much buzz, right? It was, we can use so much less processing power to understand text, content, queries, intention, and we don't need to do sentences, and we don't have to go forward or backwards. We can predictively match. So it doesn't really have a lot to do with SEO. It impacts some long tail searches, but it's not something where you as an SEO have to go, oh my God, BERT, I need to learn. And if someone has an article about optimizing for BERT, don't read it, because BERT is a pre-processing machine language for pre-processing tool for the machine learning on language. So it's not affecting the results themselves. It's what they do early in the process to try to better understand intent and what queries you put in, the relationships between them, and what you want to pull back. So if you're really confused and like, oh my gosh, because like I said, I could go on for 2 hours about BERT. This is an amazing article written for the layman on understanding how BERT works. It's really good, and I advise anybody who's interested to go read the entire thing about BERT. I'm not going to get into many more details because you don't really need to know, because it doesn't affect SEO directly. Oh, and I got ahead of myself. How do you optimize for BERT? There's nothing to optimize for, but simple answer to a very complex issue. Remember when Gary and John always say, write better content? You want to create holistic content. So optimizing for machine learning. I put optimizing in quotes because you're not optimizing for the actual machine learning, but you're optimizing so machine learning understands you better. So you want to make sure that you use nearest neighbors in language. So you want to make sure that you use similarities that are semantically related, like the Marvel comics. You can get semantic terms, your relationships, by doing a search in Google Images. As you can see, sweets is related to candy, chocolate, food, all these other terms. And so you can get an idea, if you're writing content, of what the relationship terms are, so you can write content related to those relationships. So you use a word that Google has determined is similar, so you're not using a word that Google doesn't know is similar. Also, do you have depth and width? So you want to make sure that you write about the depth of a topic and the width of a topic. And this is actually the same thing you've been doing always, but it's just way more important now because the machine learning looks at all these things to determine what your website's about. And remember these, we have the phrase-based indexing and co-occurrence, the page segmentation, and the entity salience. All these are things you can optimize for to help Google determine relevancy from your site better. And use well-formed text. So this is very, very important. This is actually part of machine learning and natural language processing. You want to make sure that your text is very well-formed, grammatically correct, and they love questions. You know why Google's an answer engine? We talked about before, and Google's always like, we love questions. It's because that's part of machine learning. It's an answer engine. It's easier for Google to answer a question than it is to determine a sentence, the context of a sentence. So when you're optimizing to do better in Google, you want to think not in keywords, but in the intent, the query terms, and the context of those terms to each other within your pages and within your entire site. And then asking and answering questions. Google loves questions because that's how NLP works on well-formed text, and well-formed text is often a question. So this is the real simple takeaway from everything we just went through. Think search queries, not simple keywords. Write in natural conversational language. Use holistic content, remember depth and breadth, and related terms. Make sure you add structured data and use well-formed text. This is everything you need to do to make sure that the machine learning understands your site better and pulls you back for more queries because it believes you to be more relevant. And if you do all that, you'll be happy. These are some tools you can look at. InLinks is a great tool to check out. It helps put schema on your site for you. And then here's a bunch of stuff about BERT and NLP you can read if you're really, really a geek like me and read all the articles. And there we go. That's how I got to Sesame Street. BERT, Ernie, and Elmo.